here, and I am help. And I am in the wrong chat room. Let's go. Let's effing go, as the kids are saying. Let's make this play. I got my audio down. Nice. Very nice. Twitch.tv rabsef. That's me. This is the ASMR edition of Homework Help for lesson 10. I was gonna like smack my lips into the phone, but that's gross. ASMR is gross. It's for nerds. Okay. Let's look at our homework and do our readings real quick. In fact, I'm not even gonna do the 8-ball because the 8-ball is really just no, I'll do the 8-ball. We'll just avoid tree sets and maps because this is just reading. Let's go to the 8-ball. Okay. Let's get this code in, and then we'll go through what's going on here. So Zapcol, we know, is going to form a stack trace. We can put it in. I just think it's unnecessary. I mean, it's not unnecessary, it's just supernumerary to what we were trying to learn here. Okay, so a say generator, the important parts of this are that we're creating a cell of say in the gate, and the gate is going to produce a cell of noun and whatever it produces. The say part tells the waycaught. It tells the dojo how to print things. It says you're going to print this as some type, and then the cask of a cask is a type and some data, and so noun plus your output forms a cask, and the cask tells the prefix of say how to print in the dojo. So it says you're going to print something, it's going to be a noun, that noun will be this thing. That's really all that's going on. The important part, though, the important part of a say generator is that the gate that you form has new parts to it that we haven't seen before. Okay, so what are these parts? Well, let's look at the generator's orbit page. And what we have here, let me get to say, there we go. The structure of the gate here is going to be like this. So the first you have now, any, beak. So this is going to be like the time, entropy bytes, and ship name. Okay, so the first thing that's in there is going to be this cell of now, entropy, beak. That's this here. So what you need to know is that a say generator automatically has access to this data. If we tar it like this, if we just put tar there, which means any noun is accepted, we theoretically could access it, but like basically we're not giving it a face, so it's going to be more difficult to access it. If we wanted to access it, we'd want to give it like a face like this. Or I like back. Okay, so you could do something like that. So that's our first argument. The next thing you can do is a list of unnamed arguments, which is an interesting term for it. Unnamed arguments still have faces. They are just when you call them in the dojo, like when you call add, right? Those don't have names there. What they do, in contrast, a named argument would be something like this. You would call it like add, and you'd have 1, 1, or the cell of 1, 1. Then you'd have like extra argument equals 2, and that would do something. So the named arguments at the end here, you have to declare them with their face when you are providing them at runtime. So let's make a simple say generator and see if we can demonstrate this. Now, is it Pat T? No, Pat D? DA? Yeah. Hey Hodwin, are you in chat? I don't know. Let me know if you're seeing the stream. I'm just going through how say generators work. Oops. Okay, so there's no problem. So there's now any and beak. Next, we're going to have a list of involuntary arguments or unnamed arguments, required arguments, whatever you want to call them. We'll call it rec 1 equals pet ud, rec 2 equals pet ud, and note that it's a list. And then we could have op 1 equals tape, op 2 equals tape. Okay. Oops. So now form another cell of noun because we want our output to produce as a noun, and we can do some interesting things here. So first, let's save this. Let's save this as say gen.test or .tone, and we're just going to start by producing a cell of now any. I know you guys love this notation. Now any Beck. Come on, buddy. Here we go. Say gen. So we have to produce required 1 and required 2. So let's give it 1 and 1. And where am I wrong here? Want have that's weird. I'm not sure I know exactly what's happening there. Oh, is it? I'm sorry. That's probably why. Oops. haven't done this in a while, as you might be able to tell here. Do you need commas between them? I don't remember. I don't think so. Oh, that's why. That's right. Beak is actually not just a pet P. It's your P and your Q. Okay, alright, so there we go. So that's what we would expect. So see this here? This is like our P and our desk and some other thing. I don't even know what that is. But so this is the cell that we've produced here. We produced the date, we produced our entropy bits, and we produced our beak. So we could do like P dot beak and get it a little shorter here. There we go. Now we could create a cell of rec 1, rec 2, beak. So now we're going to use those required arguments, and you'll note that when I call them, I can just list them. I don't even have to put them in a cell. I'm just putting them right here. We can even make it 1 and 2 to make it a little easier to see that. And there we go. We get that. Sorry, I had to blow my nose there. Next, we can do something with op1 and op2. So let's say if oh yeah, we want it this way. Op1. No, we'll do it this way. If both of them are null, then this. Else, if op1 is null, then we're going to put op2 and back, p back. I think that they changed the behavior of beak, which is interesting. Op2, op1, p back. I don't even need this. We know that this is null. Okay, let's run that. What is it not like at 4 or 5? Oh. Okay, so there we have op1 and op2 null. Here I'm going to call op1, and I have to, and this is why, going back to this line here, this is what I was trying to get at. List of named arguments. This is why they're called named arguments. And this is very confusing to me because both of the sets of unnamed and named have faces. And so to me they have names because I associate faces and names, but that is inaccurate. Here, when they say names, named, they mean that on the call to the generator, on the call to the generator, one must give the name. think you had to give both named arguments at the same time. Let's try that just to see if it... Find out to... Huh? Alright, hold on. We'll figure this out. Oh, you gotta do a comma. Don't you? Oh, jeez. I don't remember how to do this. No, I'm making a mess of this. Hold on. I'll figure it out. Yeah, so I'm confused here. Let me look at some older code. Or maybe this is how I'll do it. Here, it shows you how to do it here. Oh, that's why. The notation is like this. Derp. Okay, so you do have to do a comma. Alright, let's try this again. 1, 2 gives us that. If we do 1, 2, comma equals op1, and then tape, we get that. If we do... Oh, I can do it like this, actually. Op2. That should work. Yeah. Okay, so what we've learned is we have in a say generator some access to things that are implicit in the subject, access to faces of arguments in a list that are required by the generator, and that so just to prove this out, if I do say gen with like just one of those, it's gonna fail. So gotta provide the unnamed arguments, then access to potential other named arguments, comma delimited, with tis, face of argument, and then some value thereafter. That's how we call those. Okay, long and the short of that is this is what a say generator does. That's fun. Alright, let's look back at the 8-ball code, because that's where we were trying to get to anyway. Alright, so let's just run it. 8. Okay, so as you can see, it just gives us one of the phrases out of this list of tapes. That's great. How's it doing that? Let's go through the code. So the first thing that we need to know is that we are generating a say generator that has access to that entropy. Entropy, each time it's run, will have a different value. And so it's going to allow us to, using another core, do some randomization work based on these entropy bits. So it's kind of just like a non-algorithmically derived long number that can be used to give us some some randomness. We're going to cast our output as a tape, and our output, in fact, will be, as I said earlier, a cask of a noun, or a cask of a type noun, and then the tape. We're going to create our list of tapes of our answers. It's all these guys here. So that's pretty easy. Then this is the part where we're going to get kind of crazy. So let's look at what they say about the code, because I think that'll be helpful. Alright, random number engine. OG, note that we're using send sig here. So it's send sig, and then we're calling the whole subject of OG with the any value. So basically we're loading this OG core. We're loading the OG core into memory for ourselves, right? So OG is the core of the standard library that contains arms that perform randomness related operations. So this creates, with OG, which is a door with the sample replaced by our current any, it places that whole deal, because of the dot here, into our memory as RNG, which means we can then call the faces, like the arms from RNG, directly, right? So the next thing that we do is we create a value using the rad arm of RNG based on the length of the answers list. So we don't want to have a number longer than the answers list. And so, because what we're going to do is we're going to use it to pluck one of these out of the answers list. So if it gave us 587, right, that's no good. What we want is a random number between 0 and whatever the length of the answers is. And so that's what we're going to get. And then the last thing that we do is we snag that position from answers. So that's pretty easy. Let's look at the OG core. Do I have urbit.org up? I mean GitHub, not urbit.org. I definitely have urbit.org up. Where is the OG core? It should be in here, shouldn't it? Did I load? Oh, I load the freaking Mark one. I wondered why it was so fast. This is apparently a Shax powered RNG, which is that's awesome. Okay, so we can see the door here, right? So the OG core is a door that has an implicit sample. So when we call it here, we are saying I want that. Remember, dot gives us the subject, right? So if I dot, I get the subject. Dot gives me the subject. Dot gives me the subject. Okay, so sig, which is what this is, says give me this wing. It's not actually this arm. We've been lying to you this whole time. Give me this wing from this core, replacing the sample with this. Now, if the wing that we request is basically the one position of the knock tree, right, it's going to be the whole door. And we are then declaring that whole door to be called RNG. We could just as easily change that to, like, I want it here to be called OG as well. Right? and then we'd change it down here to OG. See that? And we needn't do that, but that's what that's doing. Okay, so we're calling the whole core of OG with the implicit sample replaced with our entropy value, and then we're using the rad arm. Where'd it go? Random in range. And so it expects some other value. It's a gate. It expects some other value. And then basically this code just gives us a random number between 0 and that, what's it called? That random number. Or that number that you gave to the gate. Okay, so that's what that's doing. The important parts here are to note how this is working. That's the RNG, and then also to note how you can start writing say generators. And there's that code that we showed here. I'll post this in chat. Okay, so there's that, so you can play with how that's actually working. Okay, so that's that in terms of say generators in 8-ball. So we have done the 8-ball reading. That's really all that there is there. We just want you to start getting exposed to the say generators. Okay, this is another reading that I'm not going to do on camera. It would just be me reading things, and that would be extremely boring. Okay, let's look at the homework. Add to this generator the ability to convert some other measurement, force, mass, volume, or another of your choosing. Temperature might be kind of cool. Add an argument to the cell required by the gate that indicates whether the measurements or distance are your new measurement. I'm actually not going to do this. I'm going to do it a different way. Enforce strictly that FR-mes and 2-mes, but note that with your newfound say generator knowledge, you can make an optional argument that would try, you could have it switch between weight and length or whatever. Enforce strictly that the from measure and 2 measures are either lengths or your type. Create a new map of conversion values to handle your new measurement conversion method. So I've already written this out. I did this with Minder last night, and we did it 2 different ways. So the first way is going to be sort of the simplest way of doing it, or like let's say the less elegant way of the 2 that we kind of derived. And then the second option will be slightly more elegant, in my opinion. Okay, so what have we done to the code? Same gate at the beginning here. We're going to have an immediate call to the arm buck of a core beneath it. So I changed that tizgal, which was doing some work here, putting in work. Let's go up and look at it. I changed that tizgal to just be barcat, because I didn't feel like it was necessary to have 2 cores here. But same difference, really. We could just as easily change this to tizgal and then have... oh no, we couldn't, because I have those arms up here. So that's right. So one of the reasons that I did do this is because I wanted to put... No, we could still do it. So, sorry. Tizgal up here, and then we could just have the core be right here. And this is going to work just as well. Um, I just think it's unnecessary to do it that way, and so I did it the other way. All right. So the arm buck here is just going to say our output is in a pad RS. We're going to check from measure and to measure. Let's go to check. So we've made some changes. Well, let's actually just look at the rest of the code real quick and we can see what the changes we made are. I have the arm check, the arm meters, and the arm output. Now there's been some code changes internal to check, but meters and output remain largely the same. I have convert to map, which you have seen before. You'll note that I've added two arms though. Much like meters, we have pounds, and you'll see that the text actually looks, it's the same text, right? And the reason for that is, I cannot do this. It didn't oh, I see. I have to do it. Right? Like that code is mostly the same. The only change is that I'm using a different map. So in pounds, I have convert weight map. In meters, I have convert to map. So basically what I'm going to do is I'm going to have two maps, right? One for weight and one for length. In the length one, we convert to meters first, and then to our output destination formula, or unit, I should say. And in weight, you might imagine, we're going to convert to pounds first, and then we're going to convert to our output measurement. And so, in order to do the output side, you're going to see that we have two output codes, which will be largely the same again. It's interesting that it won't let me just select that line. That code's largely the same, and the only difference again here is the map from which we pull. At the bottom here, you're going to see my convert weight map, which is just the same thing as what we have up here. Like, it's the same dang old thing, right? I really just copied the code. And I've done that for all the arms here. So the only structural change... Oh, and I'm sorry, we have one more thing. At the top here, I've declared this type, weight, that helps us know if the incoming PAT-TAS measures are acceptable. So the only thing that has really structurally changed is in check, I'm doing the work here. So if you recall, in our initial version, the work is actually done up here, right? You're calling the arms up here in the second expression, well, the first expression of Tisgal, which is composed second. Here, we're doing that work directly from check. So check says, if from measure and to measure are both one of the length options from this type up here, then you're going to do output and meters using those values. If both of the options of from measure and to measure as coming in are from the weight item here, the weight type, then we're going to do weight output in pounds with those values. Otherwise, we'll crash with what? This guy's fairly simple, right? Like it should be pretty easy to read through this code, and I can post this in chat as well. Let's call this basic homework lesson 10. So you can play with that later if you want. Let's look at it in Dojo. So we have oh, come on. So we can convert one plate to lbs. Huh? Scribe failed. What did I do? Oh, no, that's weird. Make Holly. Oh, thank you, dude. I was like, what is happening? There we go. There we go. Oh, see, that's not right. One plate should be 45 pounds. Hmm. It means our conversion factor's off. What did I do wrong here? Oh, okay. So this is how to convert plates. Okay, so we need this value to be 4.5 e to the 1. But nonetheless, you can see how plates will then convert to, there we go, that's better. Plates will convert to pounds, plates will convert to kilos. Is that right? 45 in kg. Yeah, that's not right either. How is this going wrong here? I think I have my conversion factors all off. So we have 45 pounds, and then we should be dividing by how many? Yeah, what am I doing, man? I think I thought I was going to do it by kilogram or something, and then I got all confused. So that's just going to be that. Yeah, that's right. It's 20 kilo plate. And then grams should just be the same number with 2 extra. Like it would be, if it's 2 kilograms, it would be 2,000 grams. Oh, that's weird. Okay, so let's see. This says that's right. Okay, so if I take minderment gram, I did it for the gram. 28094 e negative 2 lb. This should be 45. Yeah, okay, that's fine. That's right. That's right. Hey, Miter. Nice to have you, buddy. Okay. So I had some of my conversion factors off last night, my dude. But we've fixed those here. Okay, so that's the one way of doing it. Let's look at the other way of doing it. Well, before I do that, are there any questions about how we were doing it on Minderment 2 here? I'll take that as a no. Let's look at how to do it the other way. Okay, so the differentiation factor here is I didn't want to make multiple arms. I wanted the arms that we had to be the arms that we had and to suffice. No, you're fine. I didn't mean that in a snotty way. I'm just turning that off to I'm turning off my mic to take a drink of coffee and then blaming it on you. So don't worry about it. Okay. The difference between Minderment 2 and Minderment 1 here is that I didn't want to add new arms. I really just wanted my new map, and then I wanted my old arms to suffice for any condition. Right? So I still only have 3 arms here instead of having 5. Okay, so what do? Ask for our things, pad our S, then I do convert to output, convert to baseline, from measure, num, to measure. Okay, so let's look at convert to baseline from measure num first. Convert to baseline from measure, it takes as in. Value, it takes as, or num, it takes as value. And then it goes, okay, give me the cases of measurement type from measure to measure. So measurement type outputs as either weight conversion or length conversion. Those are the only types of output that it can produce, because we're using buck what there to form a union of types that are the type now, to form a type from a union of other types. And basically, as you can see here, we're using the has arm of the by door to check. All has does is it gives you a yes or a no as to whether or not this key value exists. So it goes, hey, does the key values that we were given here, do they exist in the length map? Both of them? And if so, then you get length conversion. Similarly, it checks, hey, do they exist in the weight map? Both of them? And if so, you get weight conversion. Otherwise, you get an argument or an error invalid conversion factors. So coming back down here on convert to baseline, it says, all right, there are only 2 cases of measurement type from mesh to mesh. Either it crashes, which is not a case, it gets weight conversion, or it gets length conversion, which are the only 2 cases that it can output. So we don't need a default over here. So that's what this commented code is. If you change this to cast its output as a PAT-TAS, then there are more potential cases and you need a default. But I didn't. Okay, so then we go, if the case for that output is length conversion, then the map in question will be convert length map. And then just like we did in the initial version of this, you see it here, here. Just like we did in the initial version of this, we are saying factor 1 is going to be equal to got by map in question with the in. So the map in question here is going to be the length one in this case. And then we're multiplying the initial value times the initial conversion factor for the units of measure that we initially specified, that we're coming from. Same thing happens with weight conversion, except for map in question becomes convert weight map. Yes, yes? And the same thing happens in convert to output. So convert to output is called with the product of convert to baseline. So basically our measurement in the baseline format, which is either meters or pounds, and then our destination measure. And here we do the same sort of thing. We say check to make sure, or check to give us the type here. is either going to be length conversion or weight conversion. We could probably put that. We could put that as an argument up here, but whatever. And then we could kind of squeeze in some more stuff down here. That's okay though. So all it's doing is it's getting either length conversion or weight conversion from the measurement type arm and producing that back, and then we're providing cases for that. Same thing here, map in question will either be length map or weight map. Factor 2 will be the value at the key position for the outgoing units, and we'll divide our current baseline value by the outgoing units to get our result. And so let's correct these down here too. This is I don't know how I got those conversion factors wrong last night, Minder, but note that I did. Alack, alas. And so we can, first let's do, I want to convert a SMOOT, one of them to a kilo. No, to a pound. Okay, and that's, God damn it. There we go. Invalid conversion factors. That's what we want. So we're getting that error message from up here where it goes, hey, you haven't given me two of the same kind, so buzz off. Okay. So I want to convert a SMOOT to feet, and I'll get 5.5 feet. Yeah, I really am. I'm like exactly a SMOOT tall. How tall is a SMOOT? Not smoothie, you nerd. Yeah, totally. I am a SMOOT. I am one SMOOT tall. Plus or minus an ear. Cute. Very cute. So we can convert length measurements. We can convert, as we did earlier, plates to pounds. We can convert plates to grams. We can convert 992 grams in a plate. Are grams? That's not right. I don't understand why I'm getting that weird result here though. So this should be 45 divided by a very, why is that not working? How many grams are in a kilogram? Let's see. Grams in 45. goofed for some reason, but I can't figure it out. How many? This is the factor we should have. Yeah, I think I'm just stupid and don't understand conversion factors. E to the negative 3. That's the right answer. Fudge. What a fudgin' fudge I am. Pounds in an ounce. So this should be 0.6, 0.25 e to the negative 2. There we go. That's okay. Okay. Plates to kilo. Plates to ounces. No, that's wrong. Why? Multiply the mass value by 16. I don't understand how I'm doing this wrong repeatedly. But it's not the product, it's just my brain isn't working on it. That's what I had originally. Did I commit home again? I did. Oh wait. Did I not commit home when I did this? Okay, so that was right. No, okay. 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 Alright. So that's the other way. The important thing, I spent way too much time on the dumb shit. The important stuff is to figure out what's going on with measurement type and convert to baseline and convert to output, and how I'm using what hep. And the bottom line for the reason what hep works rather than what lus, differentiate what hep and what lus. The reason that's working is because I've defined a specific type for output of measurement type. It has to be either weight conversion or length conversion. Given that that's the case, I don't have to use what lus. I would get, in fact, a mint vein if I used what lus. In contrast, if I cast the output of measurement type as a pat TAS, I would get meant lost if I were using what hep as I am. If those things don't make sense, ask me questions about them. But that's pretty much all I have for today. Let me know if you have any questions. And have a blessed day.